Hello friends, welcome to the world of chemistry. This is Dr. Vikram Panchal and I am dealing with spectroscopy for chemistry. This is the lecture of IR spectra and lecture number 32, in which I will explain you some factors affecting C double bond O frequency as well as C single bond on stretching and bending. Okay, in previous lecture I have already explained you three factors which affect C double bond O. Now in this lecture I will explain the fourth one, and that is hydrogen bonding. So normally there are two types of hydrogen bonding. In case of intermolecular hydrogen bonding, that means two different molecules combine with each other due to hydrogen bonding. In that case, C double bond O frequency decreases. Why? Because it weakens the C double bond O bond. This is the reason. For example, if you take C double O H, a monomer, in this C double bond O frequency will be at 1760 centimeter inverse. Now in case of dimer like C double bond O OH and here C double bond O OH, and there will be intermolecular hydrogen bond and this will form a dimer, and in this case the bending will be at 1720 centimeter inverse. So this is the case due to hydrogen bonding, frequency of C double bond O decreases. Now here if we take C double O ferrahydroxybenzoic acid, that is C double OH on top and then OH at para position. So here the stretching frequency will be 1680, and that is due to intermolecular hydrogen bonding. But if you take salicylic acid, where OH group is at ortho position, which will form intramolecular hydrogen bonding, and here stretching frequency will be at 1665 centimeter inverse. Okay, so here also we can say that intramolecular hydrogen bonding reduces the frequency, absorption frequency of C double bond O stretching than intermolecular hydrogen bonding. Okay, so normally because of in any case due to inter or intramolecular hydrogen bonding, there is always reduction in stretching frequency of C double bond O. Okay, now we'll go with one more factor which affects C double bond O frequency is angle strain, and that is in cyclic ketone. So if we take cyclohexanone, C double bond O appear at 1715 centimeter inverse. Now if the number of members in the ring decreases, that is cyclopentanone, then the frequency will be at 1745 centimeter inverse. In case of cyclobutanone, the C double bond O appear at 1775 centimeter inverse. So here it is clear that as the size of the ring decreases, angle strain increases, which strengthen the polarity of C double bond O group, and therefore absorption will be at higher wave number. So this way we have explained this about C double bond O. Now we'll go ahead with C single bond O. C single bond O, stretching and bending. C single bond O appears in alcohol, ethers, esters, acids, and anhydrides. First of all, we'll take alcohol. Alcohol. The C single bond O stretching in alcohol and phenols produce a strong band in the 1260 to 1000 centimeter inverse, and that is due to asymmetric stretching. The C single bond O stretching is coupled with the adjacent C single bond C stretching. Vibrations, giving rise to bands at 1460 to 1260 centimeter inverse and 1150 to 1050 centimeter inverse. So if we take RCH2OH, which is primary alcohol, in which C single bond O stretching will appear, 1 at 1350 to 1260, which will be strong band. Second at 1050 to 1000, again it will be a strong band. Now in case of secondary alcohol, C single bond O stretching will be at 1350 to 1260, which will be strong band, and second will be nearly at 1100, and it is also a strong band. In case of tertiary alcohol, C single bond O stretching will be 1. First band will be at 1460 to 1310. and it will be strong, and second band will be nearly at 1150, and that is also strong band. Okay. In phenols, interaction between OH bending and C single bond O stretching occurs. As a result, two bands in the region 1390 to 1330 centimeter inverse and 1180 to 1160 centimeter inverse are obtained. So normally in case of phenols also we observe doublet or two different bands. Okay. Now in case of ether, which is having this structure ROR dash or ROR, here ethers have C single bond OC group. So there is a broad zinc type band in the range of 1300 to 1000 centimeter inverse. In case of acids, we have RC single bond C and then C single bond O, then O single bond H. In this case, two bands arising from C single bond O stretching and O single bond H bending. So here C single bond O stretching will be at 1320 to 1210 centimeter inverse, and OH bending will be at 1440 to 1395 centimeter inverse. Okay. So this way we come to know that this is due to C single bond O stretching. Okay. In case of dimer, C single bond O stretching will be at 1315 to 1280 centimeter inverse. Okay. And C single bond O single bond H bending will be at 1440 to 1395 centimeter inverse. Okay. Next is Ester. That is RC double bond O R dash or R. So here we have C single bond C double bond O single bond O, or O single bond C, and that will give you doublet 1300 to 1000 centimeter inverse. In case of acid anhydride, we observe unconjugated anhydride gives 1047 centimeter inverse, and cyclic anhydride will give band at 1299 to 1176, and one is at 952 to 909 centimeter inverse. So that's it about C single bond O. Thank you so much.